Hi Seema, how are you doing?
I'm doing good. How are you?
Doing good as well. Thank you.
Can I get the link for previous class, which was taken on Tuesday?
Uh, yes, like it was my mistake. I forgot to send that. So today after the session, probably I will send the links
Okay,
for both the sessions.
okay, thank you.
Hi Mohan Raj, how are you doing?
Hey, good morning, everyone. Doing good, Kaustubh.
Mhm. Great. Okay. Okay. So guys, let's dive in. Share the screen. So today our focus will be on two things. Okay. First, so today we are mainly gonna focus on the programming paradigms. And we will look into two aspects. One is the functional programming. Second is we'll look into the object-oriented programming. And then we will also see the pragmatic implementation. First, we will understand these two. Though we have touched base upon with the functional programming, but we took a very small example to understand how to create function and how to use that. So today we will take one stride further. So we'll start with the functional programming, then we'll see the object-oriented programming, and then we'll see the pragmatic implementation in of both in data analysis workflow. Okay, great. So we will start with the functional programming first. So functional programming, as you can see over here, it mainly deals with writing the functions. Okay. Now, one, like before even we go ahead and see anything, let me tell you that why we have these two programming paradigms, mainly to reduce the effort on repetitive coding. So wherever you will find that there are a lot of repetitive tasks, you can think about either writing a function or creating a class or creating a module. Okay. Now, both of these programming paradigms are quite popular among the developers, and both of these methods or both of these paradigms have their own set of pros and cons. Okay, uh, and you will find like arguments in support of each and also arguments against each other. Okay. However, having said that, the main objective or the main motive behind using these paradigms is to reduce your effort on repetitive coding. Okay, because when you will uh, work on a project, you will work in multiple projects. Okay, and when you will work on multiple projects, it's very important to save a lot of time. Okay, and to increase your efficiency. Now, how you can increase your efficiency? If you can save a lot of time on repetitive tasks, and you can let the functions or the like OOP paradigm to take care of this repetitive coding. Okay. So we start with the functional programming, and we'll see a very small example first. That let's say, for example, write a function to check whether a number is positive or negative, or let's say, take this. Perform following tasks. Okay. One, check whether a number is positive or negative. Followed by second, check whether the number is odd or even. Third, find the square root of the number. Find the log of the number with base 2, and what else? Anything else? Okay. Yeah, I mean, like, this is a good starting point. Okay. So we are going to perform these 4 uh, tasks over here. Okay. And also, we will assume that we do not really have any libraries being imported. Okay. It might happen that when we start working on a project, we are not really aware that what are the libraries we need. So we will also allow our functions or uh, like whatever we do, it will take care of it. It will import the necessary libraries or necessary packages. We are not gonna do it. Okay, great. So as we know, a function is comprised of uh, like 3 or 4 parts. It starts with a number. It starts with a name. So we have to define a name. Okay. Second, we have to either we can give the input or we can provide the input within the body of the function, and then it will comprise of what it has to do in a stepwise manner, and it will also keep on giving the outputs. Okay, so over here, we start with def. It will define the function, and let's say we give a name to this function. We write, let's say, uh, num underscore ops, and we will give a value over here. Okay. Now, what I'm doing over here, I am also putting a comment. Commenting is very important whenever we write a program. Why? Because remember one thing, that you will not be on the same project for eternity. At some point of time, the project would be handed over to a different team, or some other person would work on the project. So anyone who should go through your code, okay, they would understand that what you have done and why you have done. So when you put a comment in your code, you're actually putting yourself on the code, your thought process on the code. Okay. So without, like if we do not put a comment in our code, then it's like we are not putting any guideline. Okay. It's just, for example, you have bought a gadget, but there is no user manual, nothing that how to use it and what are the functions of each components. So very important that you put a comment as well. So over here, I'm putting this comment that task one check whether a number is positive or negative. And I will start with printing this. Okay. So I'll just copy this whole thing. Now, if value is greater than 0, print the given value is positive dot format value. Well, what if we enter a value equals to 0? Print the entered value is 0. And if none of these are true, then we can go to the else and we can print this. That the given value is negative. Okay, dot format. So that is all about task one. After that, we come to task two. Check whether a number is odd or even. Okay. So we'll start with this one. And simple, if value mod 2 is exactly equal to 0, print the given value is given dot format value, else print the given value is odd and dot format. Now we go to task 3. Find the square root of the value So we can write over here is, now for square root, there are two ways. Either we can import the NumPy library and we can, like access the square root function within the NumPy library, or we can raise to the power. So over here, like we do not really need, the NumPy library to find the square root. But then next we have the log. So for log, we require the NumPy library. So in any case, we need it. So what I'm going to do, I will import the NumPy library over here. So I will write import NumPy as NP. Okay. And I will write sqrt underscore value equals np dot that. And then I will print the square root for the, okay, here what I'll do, I will make a small change. Why? Because what if we enter a number like -5? So if we try to find the square root of -5, then it will become an illogical operation. Okay. So what I'll do, I will check if value is greater than 0, then sqrt underscore value equals np dot sqrt value, and I will print the square root for the value is, and over here we will give dot format. In the first case it will be value, and the second case it will be sqrt underscore value. Okay. Right. So however, if it is not greater than 0, that means if it's 0 or less than 0. Okay. So in that kind of scenario, what I want to do, I want to raise an exception. And I will say input error please enter a positive value. That is a value which is greater than 0. Okay. Great. So we are done with the task 3 as well. Now we go to task 4. Task 4 is find the log of the value with base 2. Okay. So we have already imported the NumPy library, so we do not really need to do that. I will just first copy these 4 lines. And over here, what I'll write, same if log underscore value np dot log 2, I give here value. And then I print the log of value with base 2 dot format value comma log underscore value. Again, for else, it will remain the same. Okay. And then we will end it up with the return. So let's execute this first, and then we will see what will happen when we call this function. So you can see that it's a nice looking function so far. And then we will also talk about the problems that might arise from this function. Okay. Now I call this function num underscore ops. I think that is what this function is. And I give a value, let's say 10. So task 1, number is positive or negative. Given value 10 is positive, check whether the number is odd or even. The number given value 10 is even. Find the square root of the value. The square root of the value of 10 is this, and then task 4, it also gives us the value. Okay. Similarly, you can give another anything, num underscore ops, and you can give like minus 85. Okay. So minus 85 is negative, minus 85 is odd, and then it gives you error. Okay. And you can see that it will not go to the next one. It will be, like it will be terminated. Why? Because if it is encountering an error in one step, it will not go to the other step. Okay. So that is the first. At any point of time, if your function encounters with an error at any place, it will not go to the next step unless you do the rectification. Okay. So even if your fourth task is like it can be executed, let's say. Okay. Even if it can be executed, it will not be executed. Why? Because it would be terminated. Okay. That is the one problem with a function. Second problem with a function is it might happen that you don't need to perform all the steps for a given value. You might have to do certain selected uh, operations. But when we write a function like this, a long function like this, which is comprised of multiple tasks, that choice is not there. Okay, that choice could be there, but we have to give those dialog boxes that whether we want to go to the next step or not, like that. And that function will keep on, like it will become lengthier. So though a function has an immense, like potential, but there are certain things like it cannot be, if we put too many tasks in a function, then that function becomes quite cluttered. Okay, and if somewhere it goes wrong, then the entire function would be terminated. Entire operations would be terminated, and there enters the object-oriented programming or the modular programming. Because what happens in object-oriented programming, we use small methods, we use capsule-sized functions, and we put them as methods. So let's see. So
Kaustav,
yeah,
as we imported NumPy here, can we not import pandas here? Because you said that it might be imported already or it might not be.
over here, are we working within a data frame? No, right? So why should we import pandas? We are giving a value only.
Oh,
Pandas will make sense when we work with some kind of data. We'll see that even.
okay.
So object-oriented programming aim is to create modular codes which modular code can act as an independent function. So the very first thing what we do in object-oriented programming, we create a class. Okay. And this class will be comprised of all these attributes and methods. So how to create a class? It's very simple to create a class. Let's say I create a class like this. And I give a name to this class. Let's say val. And I write pass, nothing else. So if now I create, let's say I write num equals val. Okay. What we are gonna get over here? So it will say that it belongs to the class val, nothing else. Okay. Can we write like this? Num equals, for example, let's say val 12. You can see that we cannot provide a value to this. Why can't we provide a value to this? Because it takes no arguments. Okay. We haven't provided any argument like where it can take a value. That is the reason. It cannot take any value over here. So to provide a value, what we have to do, we have to we have to assign some attribute. Okay. And here comes and this is what we call as a constructor. That means whenever we are creating an object, we are creating the instant, like we are creating an instantaneous of this class. So now I will modify this class. I will write class val. Okay, I will start with this, but now what I have to do, I also have to provide, like an attribute to this. Okay. Once I provide an attribute, what will happen? Like it will, we can assign value to it. Okay. So how to, assign an attribute? I write over here. I write over here def double underscore init double underscore, and over here I write self comma value. And over here I write self dot value equals value. Okay. Now, if I write num equals val, like in the previous case I wrote, what will happen? You can see that we are going to get an error. It will ask us that missing one required positional argument value. So we haven't given this value. So now we have to give a value to this. And I write num equals val 11. Now if I write num, it will give a class that it belongs to the class val. However, if I write num and if I give a period, you can see that we get this attribute. And we can access this value 11. Okay. From this attribute. In fact, we can store this in this way. And then if you print this value, you're going to get 11. So what we have seen how to add an attribute to a class. Okay. So I will start here with creating an empty class and then assigning an attribute to the class. Now what we are going to do, we will see how to assign methods to this class. Methods are these functions that we have seen, these operations. Okay. So assigning methods to the class. So we'll start with this class val def double underscore init double underscore self comma value self dot value equals value. Now what we're gonna do, we will write def, and let's say the first is we want to check that whether the number is positive or negative. Okay. Positive underscore check. So what it will do, what attributes it say, self has to be there. Along with that, it will also take another attribute. What is that? It will take a value, it will take a number. Okay. Or you can also go ahead with without giving a value. Okay. So, but then what we are going to do over here, we will give this val underscore now. This is the attribute that we provide here. And what it will do, it will check if val underscore num is greater than 0. I'm not going into details, okay, because we have seen all this print in details. I'm just showing you how to add the methods. I'm not also, like increasing the length with elif and else. I'm just giving this. So that we just understand how to add the methods. Similarly, I'm just adding two methods over here because, excuse me, because you like this, you can add multiple methods. So another method is log underscore num, and again over here it will check first if val underscore num is greater than 0. What it will do, it will first import numpy as np, and then search, and then it will create np log 2 val underscore num, and it will print log of it's 2 format. In the first case, it will be val underscore num. In the second case, it will be log underscore accept. Otherwise, it will raise an exception. And I'm just keeping very short, like wrong input, like this. Now what I do over here, I write new underscore num equals val 70. So now if I write over here new underscore num dot, you can see that there are three things. Okay, this is the attribute and these two are methods. So if we click on here, it will be 70. Okay, so what I'll do rather, I will then write it in this way, that new underscore val equals new underscore num val. Now, if I write new underscore val, we'll get 70. So what I'm doing now, I will use the methods now. So I can directly go ahead and we can write new underscore num dot, and we can access the methods. First, we check the value whether it's positive or negative, and I give over here new underscore val. You can see it will write positive. Similarly, I can write new underscore num dot log underscore num, and I give new underscore val. It will give us the log of 17 with base 2 is this. So now you can see what we have done. We have split the things into modular codes, into capsule size codes. What is the benefit? Even if we go wrong somewhere, we can rectify that particular function, a small one. We don't really have to go through a long function. Okay, now the question could be where to use a function and where to use a modular code. So if you have to do one thing, one task repetitively, then you can create a function. But if your workflow is comprised of multiple functions, related functions, then you should create a class that will be comprised of all those steps. For example, I'll give you an example. Use both functional programming and OOP to perform the following. First, to check the number of missing values for each variable in a data frame. Second, to create histogram for each numeric variable in the data frame. And three, standardize the values, standardize the variables in a data frame. Okay. So I've taken 3 different kinds of operations. Okay. Why? Because that will be more fun. Okay. So over here, what we will do, we'll first import the pandas library. Pandas library is something that we probably don't have to put it in another function or in another uh, method. Why? Because whenever we have to read the data, we will use the pandas library by default. Okay. So we can start with import pandas as PD. So it will hardly require for you to put pandas within a function or within a class or within a method. But definitely, if you feel like, okay, I will create such a class which will also read the data, then in that case, you can create a method where you put importing pandas as PD as well. Okay, uh, that is also feasible. Now, but before that, what we have to do, we have to set up the notebook, which I haven't done actually. So let me set up the notebook because I have to access the drive. So from google.com, drive, drive. OS. Working directory. OS start get CWD. OS.ch dir. So So let me connect to the drive. Okay, so we are good to go. Now I will use the same data that I have used earlier as well. So data equals pd dot read underscore csv, and I give cars dot csv. Okay, so we start with this, and now either we can write a function or we can use the OOP. So first I will go with the function. I will write def df underscore ops. I give a name to this function, and I will put this data as the input. So task 1, check the missing values. Okay, and print the number of missing values for each variable. This is given below. Start with print data dot is null sum. Okay. Then we have the task to create histograms for each numeric variable. So what I do over here, right? First, now I don't know that whether someone has imported Plotly or not. So what I'll do, I will import Plotly.express as px, and then for I in data dot columns, if dot d type equals object, I will not do anything, pass, else dist equals px dot histogram data comma I comma title equals histogram for plus I. Dist dot show. And finally, we come to the task 3. To create a standardized data frame. So the first thing that I will do is I will import a copy, because I do not really want to, I do not really want to mess up with the, I do not really want to mess up with the actual data frame that we have. Okay. And over here, what I'll do, the first thing that I will do is I will create a data frame. And then I will write for I in data dot columns if data I dot d type equals object pass, else df underscore num I equals data I. And then what I'll do, I will write data underscore copy equals copy dot d empty copy df underscore num. And before scaling, I want to print the first 5 rows for the new data frame with numeric variables, just to ensure that we have got the right thing. Data underscore copy dot head. And after that, what we'll do, we'll import from sklearn dot preprocessing. We will import standard scalar, and then we will get scale equals standard scalar, and now scale underscore data equals pt dot data frame scale dot fit underscore transform data underscore copy, and then scale underscore data columns data underscore copy. And okay. So that's it. Let's see how does it work. Okay, so df underscore ops data. So you can see that everything has been worked out perfectly without any error. Okay. So let's see this. It has started with missing values for each variable. You can use it for any data frame. That is the beauty of this function. And then it will check that whether a variable is numeric or not. If it is numeric, it will give you the historical. Okay, you can see for engine size, cylinders, horsepower, NPG underscore city. Okay, NPG underscore highway, weight. Okay, wheelbase, length, MSRP. For every numeric variable, it has given. And then it has first given you the 5 rows for the numeric data frame with only the numeric variables, and then it has scaled it and it has given you the scaled values. But again, the question is, what if we do not really need to do all of them? Okay, so now I'm using the OOP. Okay. So for this, what I'll do, first I will create a class, and I can give the name as, let's say, data underscore ops. Okay. Now, or let me write it in this way: data ops. Okay. Now, do I have to assign any attribute to this? It's not required. Okay, because I have the data, I will import the data. I do not really need to assign any attribute. But always remember that I have to keep the constructor. So over here, what I'll write def underscore double underscore init double underscore, and I will just give self, and it will print okay, it will not print anything, it's not required. Welcome to the data box class. Now what I'll do first, miss underscore check, I will give self, and I will give the data set over here and print okay. Okay, I give the data over here. Yeah, guys, anyone? Any question?
So, sorry, how do you pass this data to this class, to this miss underscore check? From where are we getting this data here?
We have already imported the data, right? So we'll pass on that data. We already have the data with us. We have imported the cards data, right?
Yes, we have imported it.
So yeah, so
But-
we will pass on that data.
Okay, can
Just-
you show me how you pass that to this method class?
I will show you. I haven't given the data. I'm just creating the class, right? I
Okay.
haven't yet passed it on the data, right?
Okay, go ahead.
Yeah. Dx, and then what I'll do, I will check for in data.columns. Dot dtype equals object pass else histogram.
So what is this data dot is null? I can understand. It's gonna get all the data that has null values.
It will give you the number of missing value for each variable. So how many missing values are there for each variable? If you refer to the session, the last to last session, where I have shown every step on the data operations, I showed that to look at the number of missing values for each variable, we use this is null.
Then what does
So-
this dot sum do?
Dot sum is number of missing values for each variable. Is null will not give you the number of missing values for each variable. Okay. So dot sum means for each variable, it will sum up the number of missing values and will give you that. So that's it. Let's stick to these two. Now what I'll do, I will write, let's say, ops equals data ops. So you can see that we have got this first welcome message that welcome to the data ops class. Now, as I give ops dot, you can see we have got two things. One is either we can create the histogram for each variable, or we can look for the number of missing values. We start with this number of missing values, miss underscore check, and I give the data that we have already imported. So you can see it will give you the number of missing values for each variable. Second, we can go for creating the histogram for each variable, and I give data. So the histogram for each numeric variable, we can get this. So what is the benefit out here? That we don't really need to create one big function to perform all the operations. We can
So,
create modular.
so what is this
Yeah.
count on the, what is the count on the left side?
Okay, so this is the histogram, but which tells you that how many numbers of cars are there, which has got engine size. Let's say if I hover my cursor
Okay.
here, it gives you between engine size 1.4 to 1.5, there are 7 cars.
Okay.
If
okay.
I go here, it says between 2.4 to 2.5, there are 49 cars, right? So that's a histogram all about. And this is how we can leverage the modular programming to perform multiple functions. Because what you can do, you can create a Python file with this kind of class. And once you save this file as a .py file, not as a notebook, but as a py file, then you can import it as we import the pandas library. Because what is pandas library? It is nothing but a Python file with a lot of methods and attributes. What is a NumPy library? Again, it is nothing but which is comprised of a lot of classes with like a lot of attributes and a lot of methods. So you can store these classes into a separate file, and you can save it as a .py file. Okay, instead of a notebook file. A notebook is IPYNB, and if you want to save it as a Python file only, it will be .py. Once you save it, you can always import it like we import the other files. And once you import it, you do not really have to write the same code again. You can just access the methods as we access the methods from the pandas library or the NumPy library. Okay, and you can avoid a lot of repetitive codes that we keep on writing to do a particular task. So that's what like this session was all about, because I took like I have taken very phase wise things so that our foundation becomes stronger. What I really appreciate that like you keep on going through the past sessions, okay, that will help you to like stay updated. And yeah, from the coming week onwards, we will dive deeper into the data sets. We'll start analyzing the missing values, outliers, and then pre-processing, then developing the models. Okay, so yeah, so that was it. I will share the recording for the last session and this session along with the resources. I could not share the last session's recording, so I'm sorry for that. I will share both the recordings and all the resources. Go through it. Feel free to reach me out for any kind of questions. And yeah, see you on Monday. So have a nice time, guys.
Thank you.
Take care.
Thank
Bye-bye.
you.
Yeah, welcome. Yeah,
Thank you.
you're welcome.